Good afternoon, class. We are looking at chapter 3, derivatives, section 3.7, derivatives of the logarithmic functions. We have a big chunk of it. And here's the rest of the examples we want to look at. Y equals e to the power of 2x times ln x. First, we put a raised dot in between. It's the product of f and g. We're going to use the product rule on that. So f is e to the power of 2x. Any exponential, the derivative is itself, e to the power of 2x. The exponent is a function of x times its derivative, which is 2. And this is f prime times g, which is ln x, plus g prime ln x, the derivative becomes 1 over x, times f e to the power of 2x. So I'm going to write f prime g plus g prime f. All you have to do, take the common factor of e to the power of 2x out. This gives you 2 ln x. This gives you 1 over x. And we are done. We want to take the derivative of y equals log base 3 of square root of x. And so to do so, first I want to remind you how to differentiate this, because we haven't done this differentiation when the base is different, as we did with the exponential function when the base was no longer e. What did we do? We used logarithmic properties and exponential properties to come up with the answer. We are going to do the same thing. And so log x base b, we are going to use the change of base formula to write it as ln x over ln b, or 1 over ln b times ln x. As you can see, this is just a multiplier, just a coefficient. It is a number. So when you want to differentiate, it just remains, and then you differentiate ln x, which is 1 over x. And you rewrite it as 1 over x ln b. So to do so here, first of all, I want to use logarithmic properties. I'm going to change this to x to the power of 1/2. And then the power rule says 1/2 sits in front, becomes a coefficient, and now we are ready to differentiate. 1/2 remains. Then log, flip over the argument of log, 1 over x. The base is e, no. Therefore, 1 over natural log of the base. And we rewrite it in this fashion. So I'm reminding you, when we differentiated a to the power of x, the answer was a to the power of x times ln a. And now we are dividing by ln a or ln b when we deal with logs. In this case, we are also going to use the chain rule, because now this is a function of x. Number one, can I simplify the log by decomposing it? The answer is no. Number two, how do I differentiate log base b of f of x? First, I flip over the argument of log. Then I'm going to differentiate this, because by the chain rule, I have to multiply by f prime of x. Then I look at the base, because it's not e, 1 over ln b, and we're putting them together. So following the same format, I'm going to flip this over, 1 over x squared plus 1. Then I need the derivative of the argument of the log, becomes 2x. Then I look at the base. Since the base is not e, I need 1 over natural log of the base, 1 over ln 5. We're going to put them together and rewrite them as such. 2x remains in the numerator. These two are in the denominator, x squared plus 1 times ln 5. Y equals ln of sine x. To differentiate that, we follow this formula, we flip it over as 1 over sine x. And then we need the derivative of sine x by the chain rule, which is cosine x. And cosine x over sine x is cotangent x. ln of 5x. First, I'm going to call this g of x, which means I need 1 over g of x, 1 over ln of 5x. And now I need the derivative of that. So I need the derivative of ln of 5x. Well, what is the derivative of ln of 5x? Well, flip this over, 1 over 5x. And by the chain rule times 5, the derivative of 5x. And we're done. Notice 5 and 5 cancel each other. So the numerator is simply 1. The denominator are the product of ln 5x and x. So we put the x in front. 1 over x ln of 5x. Just in case class, if ln of 5x, you cut it in 2 pieces, ln 5 plus ln x. For this part makes it easier, but not for that part. So I would go with that. And then if you want to change it to ln of 5 plus ln of x and differentiate it, it's just as good. Okay. Example 11, differentiate y equals 1/2 ln of 1 plus x over 1 minus x. Definitely we have to decompose it, otherwise it becomes extremely involved. So this piece becomes ln of the top minus ln of the bottom. We are using the quotient rule. So 1/2 remains. This is ln of 1 plus x minus ln of 1 minus x. This is intermediate algebra, pretty straightforward, everybody. Now we are going to differentiate. Well, this 1/2 is going to remain. All you have to do, differentiate this piece, which means flip it over, 1 over 1 plus x, by the chain rule times the derivative of the parentheses, which happen to be just 1, so it doesn't change anything. Minus, flip this one over, 1 over 1 minus x. Times the derivative of the parentheses. Now it does make a difference because it's no longer 1, rather the derivative of 1 minus x, which is negative 1. And now this is the step that is the calculus step. Now everything else is algebra. To combine these two, we keep the 1/2 and we recognize 1 plus x times 1 minus x as the LCD. So this one, the numerator is simply 1, 1 times 1 minus x. This one, the numerator is plus 1, minus and minus, plus 1 times 1 plus x. And all you have to do, combine these two. Notice This one is 1 minus x plus 1 plus x, and the answer is 2. These two cancel each other. The numerator is 1. And the denominator is the product of 1 plus x and 1 minus x, which is 1 minus x squared. So the final answer is 1 over 1 minus x squared.